The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI Conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content. You can earn continuing education credits through ACI's online CEU program. Visit www.concrete.org to register. ACI Conventions provide an opportunity for networking and for keeping up to date with the latest in concrete technology and practices. This is one of 3 ACI web sessions covering the 2010 Fall Convention session entitled Sustainability of Concrete Pavement. This session includes audio and presentations for 2 speakers. Please enjoy the presentations.
Okay, our next speaker, Lionel Lemay. He's the Senior Vice President of Sustainable Development with the National Ready-Mix Concrete Association. And his topic is going to be concrete's contribution to Greenroads rating system. Lionel?
Thanks, Tim. Good morning, everyone. Let me just start out with a disclaimer. I don't own stock in Greenroads. I'm not advocating for or against Greenroads. As part of the National Ready-Mix Concrete Association's mission, we do several things, including research, education. We promote concrete, obviously, and one thing that we do a lot of is what we call advocate for concrete, and that includes things like advocating in Washington for legislation, as well as we advocate concrete in codes and standards, and we consider an effort like Greenroads a standard, and so we do participate in developing those standards. And that's why I've come to this point of being able to present to you today, because I've read through the standard, and I'm going to talk to you a little bit about how concrete contributes to the standard. I'm going to focus mainly on the positive contributions. At the end, I'm going to mention a few negatives, but I don't have enough time to go through all the negatives today. So I'm going to ask you to perhaps, if you're interested in participating in the process, to contact me, and I can help you out with providing comments to the standard itself. All right, so let's get right into it. What is Greenroads? How many people have heard of Greenroads? Show of hands. Okay, quite a few of you. If you've read it or know a little bit about it, it's a rating system. Basically, it's a metric for roadway design and construction. It basically awards points for more sustainable practices. And it basically helps quantify the sustainable attributes of a roadway. It was developed by University of Washington and CH2M Hill. And even though they developed this process, the concept is that Greenroads will become a brand unto itself. So in the certification process of getting a roadway certified as Greenroads, certified, that would be the brand that would be presented to the public. What can it do? Well, it defines what project attributes contribute to roadway sustainability. It provides an accounting tool for roadway projects. It can communicate the sustainable attributes of a roadway project to stakeholders. It can manage and improve roadway sustainability. It can stimulate the market for sustainable practices. And they claim it can save money, which in many cases sustainable practices can save money. So I believe that that's true. The overall goal is to improve roadway sustainability. What does a sustainable roadway look like? Well, this is just a brief. I can't go into all the detail of the standard. The main document's 80 pages long, and there's a 400-page guide that goes along with it. So, it's a pretty comprehensive standard. But here are just some of the brief qualities that a sustainable roadway might have. Things like lower emissions, we've heard about. Things like art incorporated into the project, including rapid transit as part of the roadway project, so bus lanes and so forth. Cool pavements, we heard about that earlier. Regional materials, using materials that were harvested and manufactured locally. Quality construction, long life, pavements with long life. Low impact development strategies, including pervious pavements and so forth, and native vegetation. So just a few of the attributes of a sustainable pavement as defined by the Greenroads standard. What does the metric look like? Again, it's pretty complex, but I'm only going to cover the basics today. There are basically 7 categories of sustainability strategies. They include the project requirements. There are 11 prerequisites that you have to meet. And so, any project that would be Greenroads certified would have to meet those prerequisites. Then there's a category called environment and water, which is worth 21 points. Access and equity, which is worth 30 points. Construction activities, 14 points. Materials and resources, 23 points. Pavement technology, that's 20 points. And then there's a category called custom credits. That's worth 10 points. Basically, you can come up with your own strategies that maybe haven't been identified as part of the standard. So you can innovate. And if you look at this, and if you're familiar with the LEED Green Building Rating System, it's pretty darn close to the same concept, or similar concepts. You collect points in evaluating your project, or not only evaluating, but focusing strategies on collecting credits or points. And depending on how many points you collect for the project, you can get a certain level of certification. Basic certification is 32 points. Silver, 43, gold, 55, and then emerald at 64 and above. My first reaction is that it seems like the threshold for the top standard at 64 when there are 118 points available seems relatively low, but I will say this, it's still in the formative stages. It's version 1 currently that they've actually issued, and you can go onto their website and take a look at. So my guess is that over time, as projects participate in the standard, they'll have to adjust these thresholds for different certification. So how does concrete contribute? I'm just going to run through a few of the credits. This happens to be Environment and Water Credit 2, runoff flow control. The goal is to mimic pre-development hydrological conditions in the right-of-way of the pavement. Basically, pervious concrete can contribute to this. By using pervious concrete, you can minimize the use of things like detention ponds or other stormwater management systems to reduce impact in terms of runoff quantity. In terms of runoff quality, again, pervious pavement could contribute to reducing or improving the quality of stormwater runoff by infiltrating stormwater into the ground versus letting it flow off of the right-of-way. There's a credit that's called Ecological Connectivity, and that is basically, there are several strategies, but one of them is providing crossings for wildlife over pavements, and this image just shows one example of a wildlife crossing. And why does concrete contribute? Because most of these crossings are made with concrete, or at least partially made with concrete. In the access and equity section of the standard, there's one credit which is called context-sensitive solutions, and as part of that credit, you can provide artwork as part of the project. And how does concrete contribute? Well, visual and aesthetic components of roadway structures are oftentimes made with concrete, so that's how concrete can contribute there. We've gone over traffic emissions reductions several times already, so I'm not going to focus a lot of effort on this, or energy on this, except that we know that concrete does save fuel. Concrete pavements, because of its stiffness, can save fuel. So this credit does provide for, if you can demonstrate that your roadway can save energy over time, then concrete, of course, can contribute to this credit. Pedestrian access, providing sidewalks for pedestrians and so forth. In other words, don't cut off the community with roadways that don't allow people to cross the roadway very easily. How does concrete contribute there? Basically, most sidewalks and overpasses and so forth, pedestrian overpasses are made with concrete. Also in this credit category is transit and HOV access, in other words, incorporating some rapid transit and public transportation as part of the roadway systems, things like bus lanes and other HOV lanes. A lot of those lanes are often built with concrete because of the heavier loading and traffic that does travel on those lanes. In terms of construction activities, there's a credit that with the goal of minimizing the amount of construction-related waste that is destined for landfills. And most concrete can be recycled, either return concrete that's either crushed and reused in concrete or as road base, or oftentimes made into landscaping blocks that can be even used as part of a roadway project. Water use tracking, basically this credit, you get points just for tracking the use of water. I don't quite understand. It doesn't seem like you get credit for reducing the amount of water you use on a project. Very odd, but nevertheless, most water that's used in concrete is tracked very closely, so concrete can contribute. Pavement reuse, this is a credit where if you reuse part of the pavement as part of a new project, you would get credit for that. And the way concrete contributes here is simply by the fact that it's has long service life typically. If you're rebuilding a part of a roadway, you can oftentimes simply rehabilitate the pavement or simply use it because it's still in good condition. Recycled materials, this is a common one, of course, in most of these rating systems, even though it's focused on the wrong area of sustainability. There are credits for recycling, and of course we know that concrete, with the use of SCMs in concrete, as well as aggregate base and aggregate crushed concrete itself can contribute to this credit. There's a credit for regional materials that provides credit depending on the percentage of materials that are produced within 50 miles of the construction site, and most concrete is produced within 50 miles of the construction site, whether it's ready mix or whether it's produced by the contractor on site. Generally would be within that 50-mile radius. In terms of long-life pavements, concrete can contribute here because it's well-known, and concrete that's designed in accordance with the current standards really meets this credit requirement. This is one of the negatives, however. When you look at the way that the credit is defined, most, including asphalt pavement, would meet this requirement. Most pavements would meet this requirement just by designing to a current standard. So we've provided a comment on this credit because we feel that it's really not defining what long life really means. It's very prescriptive in the way it's developed, it's designed. You get credit if you incorporate permeable pavements into the project. Obviously, pervious concrete can contribute here. In terms of the urban heat island effect, concrete can contribute. Obviously, we've heard several presentations already that talks about concrete's reflective nature and how it can contribute to reducing urban heat islands. There are credits for this in the standard. So why bother at all with this kind of a standard? Well, it's my personal opinion that rating systems can be very influential. They can transform a market. Let's put it this way. If you measure something, it normally gets done, right? Our personal performance at work is measured generally, and we typically do it if it's being measured. Well, the same thing with sustainability and rating systems. They can work. They can force agencies to look at sustainability. Do I think it's the right approach? No, I believe, as Life pointed out, that LCA is probably the best approach, but rating systems can be a nice surrogate for LCA if it's done correctly. But what are the specific benefits of using Greenroads? Defines the basic roadway sustainability attributes. A greater participation in roadway sustainability, that's what I talked about. If it gets measured, it usually gets done. Right now, there's no reason to look at roadway sustainability. Better evaluation of trade-offs and decisions when it comes to sustainable pavements. Allows for innovation because it is end-result oriented. And basically, you can confer a marketable recognition to a pavement that meets this standard. So, obviously, if a roadway project is Greenroads Gold, I mean, it can provide some benefits to the project and the agency that's sponsoring the project. Why are we focusing on Greenroads? Well, if I had to bet, I'm not a betting man, but if I were betting, I would say that this is kind of the front runner right now. It looks like it may become a model for state DOT, FHWA, ASTM standards, ASCE, APWA, and other groups might grab onto this standard. It seems to be the front runner, and that's only my opinion. I could be wrong here. But it looks like FHWA is performing research and development work on this standard. They are evaluating and establishing criteria for sustainability that eventually would probably be adopted by DOTs. They're working very quickly on this thing, and they hope to have something completed by the end of 2010. I don't know if that's still true or not. And the fact is, the Greenroads team, CH2M Hill and the University of Washington, is performing the work on behalf of FHWA. So guess which system they'll be advocating for? It'll be Greenroads, I'm sure. So that's why we've been involved in it. What are the next steps? Well, if you care about concrete, you should be involved in this process. You should maybe review the standard, although if you can't, I understand that. It takes a lot of time to read these things and then develop some comments. I'd be happy if you're interested in providing comments to the standard, at least providing you what we've submitted to University of Washington on this standard. I'd encourage you to go up to the Greenroads website. They've got an excellent website, well organized. I don't know if they'll be able to keep up with, if it does take off, I'm not so sure how they're going to keep up with the demand for, and the administrative portion of certifications, because it could have pretty significant demand on their time. Basically, that's my conclusion. I would suggest to you that if you do want to participate in providing comments, just send me an email or pass me your card here after the session, and I'd be happy to provide you with the comments at least that we've submitted to University of Washington on this standard. Thank you.
Good. Got time for a couple of questions or one question?
I guess, I have just a comment. I'm really happy to hear that you guys are involved. I applaud that effort. I think that you are correct in your assessment that the Greenroads system is going to get some legs, and it's absolutely critical that the concrete industry is involved. I've worked a lot with these folks, and I'm on a team with some of them. I find them to be very open to suggestions, but most of their experience has been with asphalt pavements, and it's just where they're at. So I think the concrete industry, engaging them is a great thing to do. So, definitely I'm glad you're doing this.
Yeah, I get the same impression that this group is looking for help from industry, and so I think they would take comments. I already got the impression that even before we submitted comments, that they had indicated in a couple of areas that we had concerns about, that they already had received comments on those, and they were looking at modifying the credits to accommodate those comments. In particular, let me point it out, it's really there's a credit for using warm mix asphalt. So, and there's 3 points. Well, 3 points is pretty significant in a rating system like this that only has 118 available. So, the only way to get the credits in this standard is to actually place asphalt. Well, there should be an equivalent credit for some kind of low energy or concrete. And my guess is that they will incorporate something in the standard to accommodate that. So it's looking positive.
I've actually talked to Stephen Minch about that, because concrete has a much lower energy footprint than asphalt, period, even a lower energy footprint than warm mix asphalt. So I've had that discussion with Kevin, with Steve Minch on myself, and a number of people have too. Thank you very much. Okay, our next speaker is Julie Buffenbarger. She's the engineering and architectural specialist for Lafarge North America. And her talk today will be blended cements, achieving sustainability and durability in concrete pavements. Julie?
Good morning. Today I'd like to talk about blended cements and how they may impact your project and also help achieve sustainability and as well as durability in concrete pavements. I'd also like to acknowledge Matt Miltenberger with Ternary Consulting, who did a lot of the modeling that you'll see later in the presentation. Why is there a concern with roadways today? Most of it is we look at the millions of kilometers that are around the world, and here even in the United States, we don't travel any further than 3 miles until we're at a pavement. So certainly there's a lot of requirements that go into durable pavements. And if we look at our economy and how much time and effort we use in rehabilitation, and as well as the $186 billion that are used in rehabilitation, we see that there needs to be improvement in the durability of our concrete pavements. The U.S. spends several billions of dollars, but we have to also look at that in the terms of energy usage. If we look at energy usage, which is used at looking at maintaining a single mile of freeway, we can see that it would be 200 homes per year. Also, we look at the waste, and it would be enough waste to be as much as 1,200 homes per year. When we look at the environmental impacts, certainly greenhouse gases are a topic that is prevalent in today's society, and we see them in the newspapers. 27% of the total U.S. greenhouse gases come from transportation. And certainly this is growing as we see more and more drivers on our roadways. And certainly when we see the consumption of oil that we're bringing in from abroad and looking at our economy, this also has some impact. We also have to look at how Americans, and also not only Americans, but all over the world, the transportation sector, how it impacts our daily lives, that being hours spent in traffic, which does equate to the economy, poor road conditions, which is incurred in operating costs for the motorists, and certainly, more importantly, just human life. So that's a cost that we can't even put a price upon. So let's look at the future, and what do we see on the horizon? Well, certainly when we look at transportation impacts and indicators on sustainability, they were looked at a little differently a decade ago. When we looked at economy or social or environmental, we see that some of them are the same as we would have seen a decade ago, but we've also seen that there's a large change. If we look at social, we looked at things like mobility disadvantage. Today we look at safety as a key point when we look at sustainability. Certainly before we looked at air pollution, but now we've actually targeted more to GHG or greenhouse gases, and we're looking more at climate control. So certainly noise pollution, water pollution, all of these have really elevated into the minds and looking at sustainable roadways. We see that there are a lot of sustainable transportation initiatives out there. Well, certainly these all have a place in society, whether it is in North America, in Canada, or in the U.S. They all have good parts to them, and they also have bad parts to them. But it really comes down to, let's look at what we really need to see, and that's really durability. When we look at sustainable construction, certainly when we construct our roadways, there's certain principles that really encompass all sustainable construction. Those being reduction of virgin resource consumption, reuse of resources, use of recyclable resources, the protection of nature, the elimination of toxins or CO2, as well as other gases. And what I really like seeing right now is now we're seeing more application of life cycle costing. Too many times we've seen first cost be the most important objective. Now we're seeing more towards the life cycle costing of the process. And never can we forget the focus on quality. When we look at concrete today, certainly the one thing that we're most notoriously for is the cement production. And the cement production is obviously the key trigger in CO2. But there are levers to reduce CO2 in concrete mixtures. Those primarily being using blends of supplemental cementitious materials, or also looking at innovation, but with those come challenges. When we look at concrete manufacture and production, certainly concrete itself has a very small embodied energy. And looking at concrete, typically cement is only used at a very small portion when we take into consideration the other materials that are used in concrete mixtures. CO2 can be reabsorbed into concrete, but that's primarily after it's been crushed. We really want to look at the durable standard, because when we look at the durable standard, we'll see in a couple slides in the future that really it's a durability that will help us get to a more sustainable highway. Types of blended cements, we know that there are many out there. The one that I will focus on today is a ternary blend of slag cement, silica, fume, and Portland. We're using this blend primarily because we want to take advantage of the particle size distribution that can be obtained by using these materials. Certainly silica fume being very small in nature, and the slag cement grain being similar in size, or perhaps a little smaller than the cement grain. More importantly, what you'll see in the data that we're presenting is we can really see the synergistic opportunities that happen when we use the slag cement in the ternary blend. Because as slag cement continues to hydrate over time, we can really impact the permeability of the concrete mixture. We certainly get a nice kick from silica fume up front, but really when we look at the long-term effects and the long-term durability, we're really obtaining those by using the slag cement in the ternary blend. What's also nice is that we know using SCMs, allows us to use a recyclable material, which is one of the parts that we look at in sustainable construction. Certainly, we do also benefit by using slag cement and silica fume in the same mix, as we see some balancing of the concrete plastic properties. But more so, we see a better kick in the hardened concrete properties, particularly those of durability and perhaps ASR. More importantly, when we look at substitution with supplemental cementitious materials, we can really see that there is the ability to reduce greenhouse gas levels. In a typical concrete mixture, we can see fly ash used up to 25% on an everyday basis, and certainly slag cement up to 60% or silica fume up to 8%. Now, typically 8% we see workability issues, and at other areas we have to balance this with our construction methods. Certainly a concrete contractor doesn't like letting a slab lay too long, and certainly when we're talking about roadways, we do have some advantages there that typically they are not over-troweled, and they typically go through a train where it's put into place and then a broom finish is applied, or tining, or longitudinal tining is applied, so it's a little faster. More importantly, we can see the reduction in greenhouse gas emissions and embodied energy. With greenhouse gas emissions, if we would replace in a 7,500 psi concrete mixture 50% of the Portland cement with slag cement, we could see a reduction of upwards of 45% of the greenhouse gases that would be produced in that concrete mixture. And this is where we really start to see the advantage of using our supplemental cementitious materials. As industrial byproducts, also the use of slag cement does not contribute to the embodied energy up front, and helps also in lowering the CO2. We also use less virgin material. So when using less virgin cement, we're able then to also lower the CO2. By using industrial byproducts, we're also not letting those byproducts go to waste or into other disposal areas. And more so, it's the improvement of concrete service life that I now would like to speak to. As we know, durability is really looking at an application or a concrete structure and its ability to prosper in its particular environment. Using durable materials are useful over longer periods of time because we have additional components that come into place. If we do not have to take that particular concrete specimen away or have deconstruction, certainly we have less CO2 emitted, because there is CO2 that is emitted during the deconstruction period when we're using heavy equipment. So certainly allowing it to stay in place longer and have longer durability, over time we will find that it overall uses less embodied energy, and also we have less construction debris. A very efficient way then is to look at the eco-efficiency of using supplemental cementitious materials to increase our service life. Blended cements, as I said, come in many forms. One of the new terms that has been introduced by Meta, I believe, was sustainable ternary blended cements. These are where we're seeing two complementary supplementary cementitious materials working together to achieve, perhaps in some ways, tailor-made properties, as we see with slag cement and silica fume, balancing each other in plastic properties as well as hardened properties. With sustainable ternary blended cements, these are typically with components that are at least 40% by mass, making up the cementitious materials ratio. Here's some data that has typically been collected when we look at any concrete mixture, and these would be being of compressive strength. Certainly we can see here in using the blends, and you'll see at the bottom we have Portland cement. This would be with our 4% silica fume, 6%, 25% slag. Here are our blends, 40% slag. Here's a 4% silica fume and a 25% blend. A 4% silica fume and 40% blend of slag cement, 6% silica fume and 25% slag cement, and finally a blend of 6% silica fume and 40% slag cement. Now, many of you are probably asking, why did we choose 4 and 6% on our silica fume? We have a very large pavement program in Michigan as well as in Ohio. The Michigan DOT will go up to 6% silica fume, and the Ohio DOT will sometimes use 4% silica fume. So we try to use representative averages of materials that would be allowable by the DOT. However, I will also state that being very close to a blend that's at 44% is very difficult and quite a challenge to also move through the DOT as well. But as we can see, these are typical strengths that we would imagine. Typically we might see some variation here in testing, but these are quite representative of what we would find from these blends. Now, we've also seen ASR mitigation. Now, this becomes very important in the state of Michigan as they have a lot of alluvial sands there that can be detrimental to their pavements. So certainly, when we use these blends, we can see that by using them, we're still below the maximum allowable limits for expansion in those types of pavements. When we look at the RCP test data, now we're starting to get a flavor for durability. But durability goes beyond this now. We're really looking more so long-term, what we would look at as service life. Now, the RCPs here, as we can see, the same chart follows at the bottom where we see our separated components. Now we're seeing our blends at the end. We can see what we would see as a traditional trend, certainly by the use of SCMs. The Portland cement does see some decline. This is at 28 days, 1 year, and 2 year sets of data. But certainly we can see the benefits as we get further down into our blends, where we're seeing this blend at 4 and 40%, where we're seeing very, very low RCPs. However, this really doesn't give the full story. The full story is really looked at when we really start reviewing the service life. And when we look at the service life, we can really start looking at the impacts of ions, whether they're deleterious ions or hydroxide ions, what's happening within the concrete matrix. And this is looking at primarily the diffusion properties and the capillary transport, which can lead to corrosion in the mats or any of the steel reinforcement that's used in pavements and, for that matter, bridge decks. The modeling that was done, this was done primarily by Ternary Consulting for us, was using Life 365 model, and this was done in the expert mode. Also, we used the Stadium software, so we could look at both applications. Now, Life 365 and Stadium models operate a little bit differently. I'm not going to profess to be an expert at this, so that's why Matt's in the audience. If you have some of those questions, he can answer them for you. But what we have seen is that when we look at the chloride diffusions using the ASTM C1556, we can see what we would expect, where we would see the diffusion coefficient is being lowered over time. Now, you notice we only have 28-day and 2-year data. You're probably saying, well, we know you had to do this for 1 year. What we found very interesting is that the concrete specimens were so dense and we could not actually have any permeability occur at 1 year. We had done the testing using the regular testing protocol, which is at 35 days ponding. However, no ions were really getting in at any substantial depth. So we had to go back and retest those, and we ponded them for 70 days. We found, again, we're not getting enough chloride into the samples to really look what we're trying to get at, which is at the actual diffusion rates. So what we finally did is our 2-year is that we actually ponded the specimens 140 days. Now, this is 4 times the testing protocol. So you can see by using both the slag cement and also the silica fume that we've created an extremely dense structure which would increase the durability substantially. So when we look at the chloride ion again, we can see very good performance from 25% slag and very good performance from 40%. And then we also see the blends which come down here at a very, very low level. Now, economically, we also see benefit here. Economically, slag cement is traditionally less expensive than your traditional Portland cement in some markets. It varies across North America. But certainly we could see more economical aspects versus a straight Portland cement mixture. When we look at the hydroxide diffusion coefficients, and these are coming from our Stadium modeling, we see something very similar. So the similar trends are the Portland cement is really not changing very much at all. But very interesting enough is neither is the silica fume at 4%. So we can really see a change here when we start using our slag because of the long-term hydration that goes on using slag cement. So we're really starting to see that synergistic opportunity by using something like a silica fume, which will reduce permeability, but then at lower and higher blends, we're seeing even lower hydroxide contents. These were at 1-year data. If we look at the corrosion service life, we can also see the critical threshold here for black steel. So when we look at our ordinary Portland cement, we're seeing the time to corrosion here is very soon at almost 11 years, and we'll show this in a graphical formation in a second. Then we have 25% slag. We can see that the 4 and 25% blend of slag cement and silica fume, 4% silica fume, is very similar to just 6% silica fume. The benefits in using a slag and silica fume blend is much easier to work with the contractor, better capability of mixing at the plant. Certainly by using those have batch silica fume at the plant, there are issues where you have to maybe use bags and there could be balling and there's a variety of issues that happen at the plant when we use higher percentages of silica fume. So we see this as a really nice opportunity to perhaps remove some of the issues we might have at concrete production and balance it also with some of the properties, both on the plastic side and on the hardened side. Similarly, if we go to 40% slag, we see even lower and longer term to corrosion, which would be at about 33 years. And certainly with our 4 and 40% blend, as we would expect, is our top performer. When we look at the Life 365 versus the Stadium, as we said, I should have mentioned before, these are run at 658 pounds per cubic yard at about a 0.45. Most of these were actually at about a 0.43 as some water was held back during the mixing. And these were all at 6.5 to 8% air content along with a 5 to 7 inch slump. But going back, we can certainly see that we do see differences between the Life 365 program that is available and also the Stadium program. So we can see better correlation when we're actually at some of the blends in comparison to the correlation that we might see with a regular Portland cement concrete or with just silica fume. So very interesting data that comes out of this programs. Now let's talk a little bit about the impact when we talk about life cycle assessment and life cycle costing when we use these types of ternary blends. Certainly life cycle assessment is really a technique for just using what I would call, some people call it carbon accounting or greenhouse gas accounting. And certainly when we do that, we have to look at all the items that come into raw material acquisition, manufacture, maintenance, and disposal. We can do environmental performance by using any of the programs that are out there, such as NIST, and it would give you some environmental indications. We can marry that, however, and this is where it becomes very nice, when we model this with life cycle costing. And certainly when we look at a score or an economic and environmental performance score, we can see that using supplementals actually is a much better prospect. More importantly, as I said, service life becomes very important because now our materials have some embodied energy, but the operation, which is our lighting, which might be our main cost on a major highway, is actually now our operational energy becomes the foremost. Well, what's nice in using the slag cement, as it provides lighter pavements, we might be able to also reduce those energy costs because of the lightness of the pavement. So certainly by using these blends, we can find that design long life and durability allows and affords us, less embodied energy over the course of time. So if we look at this particular infrastructure life cycle, if we can extend the service life, which is the most important thing, we now can help impact some of these environmental indicators, economic indicators, and social indicators, those being things like vehicle repair costs, repair-related congestion, roadway accidents, and then certainly on the environmental side, energy consumption and material resources. Our challenge is right now that people are used to fast construction and not sustainable construction. And certainly there needs to be a lot of work to be done in code, standards, guidelines, and training with these type of products. The other challenges are there's not really adoptable measurements that have been used overall, and the metrics are still being developed. Long-term cost basis analysis and performance-based criteria really need to come into play here. But in closing, in using sustainable materials, such as Ternary blended cements, we offer a variety of environmental considerations and sustainable considerations, such as reductions in CO2, higher albedo values, which means lighter colored pavements, which may increase safety for our motorists as well as decrease our lighting energy costs, and then reduction of our virgin material use. More so, durability remains the key to lowering the overall embodied energy. So sustainability is here to stay, but we need to minimize our impacts using our concrete mixtures. Recycling products is very important in today's world, and sustainable ternary cements can help with that. Thank you.